This is an Excel spreadsheet of some car data, and it's just a description here which is really important. You see there's 60 models of new cars taken from the market in New Zealand in 2000, and they measured the region where the car was made, number of doors for that car, the engine size, the weight, and the price. So over here, for example, this first one here in row 2, and I've just highlighted the whole row so you can see it. It's an American car with 3 doors, 1300 motor, 871 kilos. Yep, it says kilos here, and it was 18,995. Next car on our database is Asian 5-door model, 1343 cc's, just under a ton in 25,500. So when we scroll down on the spreadsheet, we can see indeed that there's 60 cars because the first row has got headers. Now over here is a set of questions about this data, because the data is like a square. So down the columns we have each variable. So the door is a variable or a measurement of the cars. The engine is a different variable, so is the weight and the price. And bivariate, or this topic, means that we're going to be looking at 2 variables at a time. And what you have to do on your own is to choose which 2 variables you would like to investigate and come up with an investigation question. So here's some questions here that are already done for you, and they're quite good questions. It says, can the size of a car's engine be used to determine its weight? Do any of their variables help to explain the price of a car? Do any other pairs of variables have interesting relationships? So we can answer all of those questions with statistical knowledge, and we can answer them fairly well. So let's do the first one, which is more specific because it mentions the car's engine size and its weight, and it's asking, are those 2 variables related? So that's your basic bivariate question, engine size and weight. So that's these 2 here. So I highlighted the columns, but I'm just going to highlight it again, just the data itself, because when I highlight the columns, I'll show you in a second, if I just highlight C and D, the highlighting goes all the way down the page endlessly. But if I just want the block of data, I'll just highlight the block of data that I want. Okay, now I'll just get the data itself. Can the size of a car's engine be used to determine its weight? What I'm going to do is make a plot of that. So I go into Insert, Scatter Plot. Now I choose a scatter plot that is just the dots, just the points, with no lines through it. There it is there. I don't need a little tab telling me it's one series because I know that it is. If I float around on my graph, I'll show you this feature later, but we've got pairs of connecting points. So this point here, for example, is 5,000 on one measure and 1,500 on the other. So I'm thinking the engine goes up the highest numbers because I'm looking at my data. So this would be the engine size, and this axis here would be the weight. And I know that's true because when I have a set of data in Excel, it always puts the leftmost one on the bottom and the rightmost one along the vertical axis. So what I need to do now, every good graph needs to have some labels. I'm going to start with the chart title above the chart. Now I'm just going to call it, oops, just click in that chart title, and I'm just going to change it to engine size versus weight of car. I'll just put of cars. Next, back to the layout menu, I'm going to put some axes titles. Horizontal was my engine size, so I typed that in there. Now I need to know what those units are, and I think it told us that it was in CC, so I need to put that on the label, and that's an accurate mathematical graph. Okay, te pai. And then on my vertical axis, I think I'll do a rotated title. And I'll put weight, and of course the units, and I put those in brackets, kilograms. So that's a complete graph now. It's a scatter plot. I can't show you my little trick. I wanted to show you how we can isolate some of those points. We'll perhaps do that later on. Now, one last thing. If I want to present that as a more balanced and proportional graph, down here we have different tabs of spreadsheets where we could do different analyses, and I'm in sheet 1. But if I right click on this graph, I can move the sheet instead of an object, because this is like an object embedded in a worksheet, I can put it as a new sheet, and I can change what it's called. I can put eng versus weight graph. Okay, and you'll see that down the bottom here next to sheet 1 is the graph itself. And what's good about this is you can copy it. So if I right click that, I can copy and take it to a Word file if I choose to. But that's how we draw a graph.